Good morning, students. In the last lecture, I have taught you the basics of some application of trigonometry. Now, I will be directly uh, calculating or directly solving the equations. So, I have already told you this elevation is a line of sight, and this is a line of sight object and deviation and horizontal level and depression object. Example number one. What this is, a tower stand vertically on the ground from a point in the ground is 15 away meter from the foot of the tower. Already given this from the foot of the tower just 15 meters away. The angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. How will you calculate the height of the tower? So example one. What this says that, so this is my tower, and from 15 meters away, just 15 meters, there is a point, and from this to the top, the angle of elevation to top of the tower is 60 degree. This angle means is going to 60 degree. I'm assuming this is my A, B, and C, and since this is a tower and this PC is a ground, so it is 90 degrees. So this is given to find the height of the tower. Find the height of the tower. Now, in this distance you need to find. Now, how will you do this? Now this is you can. What you do this is that the see height of tower is AB. You need to calculate the AB. Base is the BC is given. In with respect to 60 degree, BC is the base and AB is the perpendicular. So perpendicular by A base is tan theta. So which implies just tan of 60 degree in nothing but this is AB by BC. Now AB you don't know which is height of the tower, and BC you know this is 15 degree. Now tan of 60 degree already know this is root 3. So this value will be equal to root 3, which implies that AB is nothing but 15 root 3 meters. This is the answer. This is the answer. Now, next is example 2. What example 2 says that? It says that an electrician has to repair an electric fault on a pole of height 5 meters. The pole height is given. So here it is a girl or lady. So it is written she needs to reach a point 1.5 meter below the top of the pole to take the repair work. What should be the length of the ladder that she would should use, which when inclined at an angle 60 degree to the horizontal would enable her to reach the required position? Also, how far from the foot of the pole she placed the foot of the ladder. So it is given height is 5 meters. Height of the pole is 5 meters. When electric fault on a pole of 5 meters, so electric pole on a height is 5 meters. So it is given that this length is given to be 5 meters. So by 5 meters. Now she needs to reach a point 1.3 meter below the top. So below the top this is 1.3 meters. So 1.3 meter below the top. So from here we need to reach 1.3 meters. So she needs to reach here. So the remaining distance will be nothing but 5 minus 1.3, which is nothing but 3.7 meters. So this distance will be 3.1. I am marking this as this is my points, and suppose this is my point when I need to fix my ladder. So it is given what should be the length of ladder that she should use, which when inclined at 60 degree. Suppose this is a point which was inclined at 60 degree, so she needs to reach this point here. It's difficult to make a straight line. Yes, okay. So it is given that this angle is 60 degree. This is my ladder. I have to find the length of this ladder, and let's say this is my point A, this is my point B, my point C, and this is my point D, and this is a pole which is erected at this erected angle of 90 degree. So there it is also, it is need to, what you need to find is that in this question we need to find is this distance we need to find, and even this distance we need to find. So how will you do this? So here 5 meter is just for it given pole. Now you need to see in triangle. So in triangle A, so not triangle A, triangle BCD, angle C is 90 degree, angle D is 60 degree, and one thing is given to be used as BC is, we have calculated this is 3.7 meters. Now for calculating for calculating CD, what is CD with respect to 60 degree angle? That is with respect to this angle. This is my base and this is my perpendicular. So perpendicular by base. So perpendicular is nothing but tan theta. So tan of 60 degrees, what? This is BC by DC. BC is given to be 3.7 meters, and DC you don't know. And but you know that this sin tan of 60 degrees root 3. It implies that DC is nothing but 3.7 by root 3 meters. So anything else is doing, so value of root 3 will be 1.73. So put in 1.73, we can easily calculate this. Now next is the CD you have calculated. That is distance of, that is what is the CD, this is how far from the foot of the pool she should place the foot of the ladder. So the foot of the ladder must be placed at a distance of 3.7 by root 3 meters. And what is the length of the ladder? So length of the ladder is BD. Now with respect to BC and BD and with respect to angle 60 degree, so this BC is perpendicular and BD is hypotenuse. So perpendicular hypotenuse sine of theta. This sine of 60 degree is BC by BD. Now what is BC? BC already you have calculated 1.73 meters, and BD you don't know. But sine of 60 degree is going to be 3 by 2, which implies that this is equal to 3 by 2. So BD is nothing but 3.7 into 2 by root 3 is nothing but 7.4 by root 3 meters. So the length of the ladder is 7.3 by root 3 meters. That's the answer. That's the answer. Now next is example number 3. What is example number 3? Example number 3 is an observer 1.5 meter tall. So the height of the observer is already given. Tall is 28 meters away from a chimney. Okay, 8 meters away from chimney. The angle of elevation to the top of the chimney from her eyes is 45 degree. What is the height of the chimney? So if you draw this, this is 1.5 meter is the height of the observer, and with respect to this we have drawn the solid line. I need to draw this dotted line. This this is suppose this, there is a chimney, like the chimney here, and it is resting on the ground, and the angle of elevation to the top of the chimney is given to be, see, observer is 1.5 meter tall, 28.5 meter away. So this is 28.5 meters away, 0.5 meter away, and this height is 1.5. He is 1.5. She is 1.5 meter tall. So she, and the angle of elevation of her eyes is 45 degree. And for doing this, she needs to elevate his eye up to angle of 45 degree. And let me rename this as, this is my A, this is B, and this is C, and this, let me say this is D, this is E. And this angle is 90 degree, and this angle is also 90 degree. And so since this is 90, this is also 90, and this becomes a parallelogram. This is the parallel. Now what you need to calculate is, what is the height of the chimney. So you need to calculate this thing. You know that this is AB plus BC equal to AC. This you need to calculate. So BC you already know, this BC will be equal to DE, nothing but 1.5 meters. 1.5 meters. Now 1.5 meters given. Now you can see in triangle ABE. And we need to see this triangle ABE. This AB equal to DC, which is equal to 28.5 meters. 28.5 meters. Now, AB you need to find, and this is given to, and this B is given, or you have calculated to be, that is 28.5 meters, and this angle is given to be this is 45 degrees. So with respect to 45 degree, my AB is perpendicular and my EB is base. So perpendicular by base is nothing but tan theta, and theta is 45 to tan of 45 degree, nothing but AB by B. So tan 45, you already know that tan 45 is 1. So AB is you don't know, and B you have calculated this is 8.5 meters. This implies that AB is nothing but 28.5 meters. Now, what is the height of tower? The height of tower is given to be AC, and AC is, you have already shown that this is equal to AB plus BC, and AB you have calculated is 28.5 meters, and this is 1.5 meters. So if you calculate this 30 is 30 meters. So the height of tower is, or the height of this tower or chimney, yes, chimney is given to be, or chimney is 30 meters. Now you see this will also be given to be 30 meters. Now from a point P on the ground, in any question, any trigonometric question, every time you need to draw this diagram, because if you draw this diagram, this will first make you understand the question exactly. You can even make some assumptions here, or even can do construction here. And second thing is that from the point of examiner, he will or she will get clear. She will get clear in his mind that the candidate knows the answer and can analyze the question, and so even it will fetch you marks in many cases. So example number 4, it is from a point P on the ground, the angle of elevation of top of a 10-meter tall building is 30 meters. A flag hosted on the top of the building, and the angle of elevation of the top of the flag staff from P is 45 degree. Find the length of flag staff in the distance of building from point P, taking 3 as 1.73. So example number 4, it says that point P on the ground, the top of a 10-meter building. So from the top of a 10-meter building, I'm drawing my building in a point P on the ground. Point P on the ground at the top of a building. The percent is my A, this is my B. The angle of elevation is given to be, this is 10 meters. This is my 10 meters. And this angle is supposed to be, this is given to be 30 degree. And flag is hosted at the top of the building, and the angle of elevation to the top of the flag staff, from the flag staff it is 45 degree. So see, you can see that from P it is 30 degrees this, and 45 degrees greater than 30, so this will be above this. So even if you don't know what is flag or flag staff, also this elevation, it is like this. This is my flag staff, and from this you can see that this is my elevation to this will be 45 degree. This is 45 degree. The whole thing is 45 degree. This is my flag. This is my flag. This is 45 degree. And what you need to find the length of the flag staff and the distance of the building from point P. So what you need to find is, you need to find this thing first, and this length of flag staff. You need to find this. Let me suppose that this is A, P, B, and this is my, let me suppose this is my point C. Point C. So in so let me first this is in triangle A, B, P. You can see that angle P is 90 degree. Angle P is here. So angle P is 30 degree. So from here, if you conclude PB, you can see that this is PB and this is AB. This is AB by this with respect to angle 30 degree. This AB is perpendicular, and this BB is base. So perpendicular by base is nothing but tan theta. So tan of theta is 30 degrees. Tan of 30 degree is nothing but AB by PB. Now what is AB? AB is given to be 10 meters. PB you don't know, so you write PB. Now but tan 30 is, you know that tan 30 is 1 by root 3. So from here we you get that PB is 10 root 3 meters. 10 root 3 meters. So this PB is given. This is distance of point P from the building is 10 to 3 meters. Now, what? How will you calculate CA? So you in next triangle, this is in triangle CBP. Again, angle B is 90 degree, but this time angle P, or you can say that angle P is nothing but CPB is nothing but CPB is nothing but 45 degree. And this time you will get that this is 10 root 3 meters. PB 3 meters. Now CB by PB. So PB you have already calculated, this is CB, and this one 45 degree. This is perpendicular and this is my base. So tan of 45 degree, perpendicular is 90. This perpendicular base tan theta. So tan theta is 45 degree. So tan 45 degree is CB by PB. Now CB you don't know. CB don't know. So I will CB and PB have calculated as 10 root 3, and you know that 1045 is 1. It implies that CB is nothing but 10 root 3. Now CB you know that is 10 root 3, and AB is given to be 10. Now so it is from given that CB is nothing but CA plus AB is going to be CB, nothing but this is 10 root 3. Now CA is, you don't know, this is height of Flagstaff. This you only need to calculate, and this AB you have, it is given the coordinate 10 meters. This is 10 root 3, so which implies CA is nothing but 10 root 3 minus 10, which is nothing but 10 of root 3 minus 1 meters. Now CA, if you get from this that CA is 10 using 1.732, this is minus 1, which is nothing but 10 into this is, if you subtract, but this is 0.732, and if you calculate this multiplied by 10, this is 7.32 meters. So the value of the length of the Flagstaff is similar to 7.32 meters, and just in the point P from the base of the building is 10.3 meters, which is the answer. Now next question is, see they are also calculated this and something like this, and then that is 7.32 meters. Now example 5, the shadow of a tower standing on a level ground level. This level ground is the same thing, is found to be 40 meters. The shadow, that see the length of the shadows in a level ground is 40 meters, longer than when the sun is at 30 degree than when it is 60 degree. Okay, when the sun's altitude is 30 degree and when it is 60 degree than when it is 60 degree. So if you draw this diagram, example number 5, if you draw this diagram, see when 30 degree, this is like this, something, this is 30 degree is like, I'm suppose this 30 degree. Now this 30 degree, the point shadow casted by this to be like this, and when it goes to 60 degree, this 60 degree, it is like this. So it is given that the shadow of a tower standing on a level is found to be 40 meter longer when it is at 30 degree than 60 degree. So this 40 meters, this is 60 degree, this will be my height when it is 60 degree, and this whole total will be my height when it is 30 degree. So this difference will be this much, and so this much is given to be 40 meters. So, and this is what else is given, 30 degree for 30, find the height of a tower. So you need to find the height. So this is, so from the figure you can see that this is 30 degree and this is my line, so this angle will also be 30 degree. This is my 30 degree, and since this is 60 degree, so this will be my also 60 degree. And let's just suppose I am taking this one, taking to be A, and this is to be my B, and this to be my C, and this is 90 degree, and let's suppose this is my D. So in triangle A, only this much is given. Yes, so this is triangle ABD. Triangle ABD. See, this is you need to find. So, and relation in horizontal basis is given. So perpendicular by hypotenuse is a perpendicular by base with respect to angle 60 degree. So I will write this tan of 60 degree is nothing but AB by BD. AB you don't know, so I will write this my AB, and BD, yes, BD also you don't know, so this is my BD, but nothing but same this and 60 root 3. Now you need to get the relation between horizontal basis on horizontal. So BD equal to AB by root 3 meters. So I am writing this. This is my first relation. Now in my triangle ABC, this is angle B equal to 90 degree and angle D equal to 60 degree. You need to write this. In triangle ABC, you see that angle B is equal to 90 degree, comma, angle C is given to be 30 degree, and one more thing is CD equal to 40 meters. CD equal to 40 meters given. Now, how to proceed with that is, this also I will write the same relation, just tan of 30 degree. Tan of 30 degree is nothing but AB by BC. Now AB by BC, yes, AB by BC. AB also known to BC, also known to, but horizontal distance unknown. So this is tan of 60 degree, 30 degrees, this number root 3, which implies that if you calculate the BC is nothing but this is AB root 3. AB root 3 meters. Now what is CD? CD is nothing but it is BC minus BC minus BD. Now BC you have calculated this is AB root 3 minus AB by root 3. Now if you substitute the value of CD as 40 meters, which implies that this is 40 equal to AB is nothing but root 3 minus 1 by root 3. Minus 40 equal to AB, and if you take the LCM, this is 3 minus 1 by root 3, which is, now if you directly come from here to here to save the space, so this is 40 equal to AB into 2 by root 3. So this 2 and this 40 is 2 under 2 into 20 is 40. So this AB is nothing but 20 root 3 meters, which is the height of the building. Just or you have to just tower. So this if you add to this 20 root 3 meters. Now sixth is the angle of depression of a top and the bottom of a 8-meter tall building from a top of multi-story building are 30 degree and 45 degree respectively. From multi-story building, the height of a top and a bottom of a 8-meter tall building from a top of a multi-story building. See, 8-meter tall is a small building, and there's a multi-story building with many stories, many floors. At 30 and 45, define the height of the multi-story building and the distance between the two buildings. Okay, so how will you do this? Simple. No need to apply your brain. Just draw the diagram. Everything is possible if you draw the diagram. Example 6. Example 6. What is given that this is 8-meter tall. Okay. And all depends on top and bottom of 8-meter tall building. See, this 8-meter tall building from multi-story building. This multi-story building. So this multi-story building always greater than the normal story building. And this is to be this, and I'm just going like this. And the building will be like this. And if I join this, if I join with this line, I have drawn this diagram, and if you join this 2 point, yes, if I join this like from here, I'm joining this, and from next point is just from here, and we're joining like this. So angle of depression was given to be, and I have this my straight line. If I will get this is my 30-degree angle, and this is my 60-degree angle to the top and the bottom of the building. This is given to be 30-degree and 60-degree, and depression 45 degree. Sorry, 45 degree, 45 degree, and this is my 30-degree. So, and the height of the building, smaller building, this is 8 meters. Now, if you clearly see that this now, since this is 30-degree and this is connected to this, so this angle will also be 30-degree. And since this angle is 45-degree and this is making like this, so this angle will also be 45-degree. And this is my 90-degree, and this is my ground. Now, and what you need to find is the height of the building. This is this thing I need to find. Sorry. So this distance I need to find, and this also distance I need to find. Also need to find. So I will be able to find this distance by using this 8 meters. Now I will be renaming this is my A. I will rename this is my B. This is my C. This is my D, and this is my E. Now, in triangle, this thing is given to me, so I will be using this. So in triangle ACD, this 45 is given, and I need to find AC in DC also, but ED is given, so this is BC. This is also 8 meters. Also 8 meters. This is already given, and this 30-degree. So this is 8 meters. So this in angle to ACD. So the thing is given that is 8 meters. Sorry. This is 8 meters, and this is 30-degree and 45. Find the height of the two buildings. This is 2 buildings, and find the height of the windows of building. 8 meters, and so this. If you apply this tan of this is tan of 45 degrees, so this is tan. This is my perpendicular, this is my base. So this is nothing but this is AC by DC. AC by this, from here you can see that DC is nothing but AC, and this tan 45 in 1, so this is DC equal to AC. DC equal to AC. Now next is in triangle. This in triangle, so this one know that this angle C is 90 degree and angle D is 45 degree. So from here is into now in triangle triangle ABE. Okay, triangle AB is angle. See this, if this is 90, this is also 90 degree. So angle B is equal to 90 degree and angle E is 30 degree. So from if you apply tan of theta, this tan of 30 degree is nothing but AB by BE. But okay, ABE. From here to this 1 by root 3. So this will also be 1 by root 3, which implies that is equal to BE. BE is nothing but AB root 3. AB root 3. And from the figure you can see, from here you can figure from the, you can see that this BE equal to DC. So from this is from 1 and this I think this is 2. So from 1 and 2 this BE equal to DC, which implies that this B equal to DC, so this will be AC. DC B is given to be AB root 3 and AB root 3 and DC, and DC you already know DC equal to AC. AC and AC is AB root 3 and AB is AB plus 8 meters. So here you can see that this is nothing but, if you take AB to the left hand side, this is root 3 minus 1 equal to 8, which implies that AB equal to 8 by root 3 minus 1. AB value is 8 by root 3 by plus 1. Now if you see this is the AC will be AB plus 8, which is nothing but 8 by root 3 minus 1 plus 8. If you take the LCM, this is 8 and you take 8 common, this is 1 plus root 3 minus 1 by this will be root 3 minus 1. So if you take this minus 1, this plus 1 get cancelled, this is 8 root 3 by root 3 minus 1 meters. And if they also did the same thing, this is, but they PD, they have taken PD, so the height of multi-story building, and they have added 8 and they have taken this thing. This will only result in one and the same thing. Now another question is, example is that is from a point on a bridge across a river, the angle of depression of the banks of the opposite side of the river are 1345 degree. Find if the bridge is at a height 3 meter from the bank. So find the width of the river. Now, how you can do this? How to do this? This is example number 7. So the example number 7 says that there is a bridge of height height of a bridge, and it is bridge height is given to be 3 meters, and for depression of the opposite side of the river, banks of opposite side of the river. Okay, so let me suppose this is my, see this is 130 degree and 145 degree. So this is my this is like this, and this river is flowing, there's a bank, so the river is flowing like this. From here this it is given that the angle of the angle of depression is 30 degree and 45 degree respectively. So at one side it is given that the angle of depression is 30 degree and 45 degree. So here you can see that this is much closer, so this angle will be here, the angle will be greater. So this will be my 45 degree. If I join this to, so this is my 45 degree, and this, if I add this is my, oh sorry, I will write from this is my 45 degree, and if I join this the angle depression, now for this, because why this, because this is my depression, this is 45 degree, so this is 45 degree, and for angle this is 30 degree, so this angle will also be 30 degree, and this is straight, so this is my 90 degree. Now the question is given that, and this is 3 meter, height of this is 3 meters, so this height is given to be 3 meters. 3 meters. Height is going to be 3 meters, and it is saying that you need to find the width of the river. How will you find it? So now let me rename this is my A, this is my B, this is my C, this is my D. What is the width of the river? Is this? So what is saying that you need to find the value of BD. Ultimately, one need to do that. Just need to find the value of BD. BD equal to what? From here, first in triangle ACB, you know that angle C is 90 degree, and BC you don't know. AC you know. AC is going to be 3 meters. Now you need to find for BD, you need to find BC and CD. You need to find this and this, so in order to get the value of BD. So from this, with respect to 45 degree, this is my perpendicular and this is my base. So tan of 45 means tan tangent, because tan is perpendicular by just tan 45 degree, nothing but AC by BC. This is given to be my 3 meters, which implies that this tan 45 degrees 1. This will also be equal to 1 minus by BC, which implies BC is nothing but 3 meters. 3 meters. Now this is 3 meter. Now in triangle, now I am seeing that in triangle ACD, angle C is equal to 90 degree, angle D is 30 degree. Now from here you can see that this, from this also, this is my perpendicular, and you can CD, so this is my base. But my base is nothing but tangent, so I need tangent of 30 degree, nothing but AC by CD. So tangent to 30 degree is nothing by 3 equal to AC. AC is nothing but 3, and CD is, we don't know, so CD nothing but 3 to 3 meters. 3 to 3 meters. So BC plus CD is BD. So what is BD? Just width of the river. Width of the river. The river. Nothing but this is BC plus CD. 1 to 3 plus 3 to 3. Nothing but 3 into 1 plus root 3. Root 3 meters. It's the answer. Simple question, simple answer. Or why? How will it become simple? When you draw the diagram. 3 1 plus 3 meters. So see, this is 3 1 plus 3 plus 1 meters. So in the next lecture I will be covering this exercise. This is a huge exercise of 16 questions. It will be very difficult for me to do this, so I will take few questions here, so that my next lecture will be a bit smaller. This lecture will equalize this. So it's exercise 9.1. Exercise 9.1. So I will be starting with exercise 9.1. Is question number 1. What does question number 1 says that art circles artist is climbing a 20-meter rope, which is stretched and tied from the top of a vertical pole on the ground. Find the height of the pole if the angle made by the rope with the ground is 30 meter. See figure this. They have already made the figure, so you don't even need to apply your brain. That this is going to be 90 degree. Assume that is 90 degree, and this is ABC, A, B, C, and this is given to be 30 degree and 20 meters. 30 degree, and this is going to be 20 meters. And what is it saying? That is title 20 meters is tightly stretched. Find the height of the pole. Yes. So this you need to find the height of the pole. So what is height of this? This is with respect to 30 degree. This is perpendicular, and this is hypotenuse. So perpendicular hypotenuse is sine theta. So sine of 30 degree. So sine of 30 degree is nothing but AB by AC. And what is AB? AB you don't know. I will write AB only. This is 20 meters. So this is 20 meters. And sine of 30 already know this is half, which implies that AB is equal to 20 by 2 is nothing but 10 meters. 10 meters is the answer. Now, example number 2. Sorry. What is example number 2? A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground. Okay, the top of the tree touches the ground, making an angle 30 degree with it. Okay, the distance between the foot of the tree to the point where the tree broke touches the tree up to the point where top of the tree touches around 18. Find the height of the tree. Find the height of the original tree. It's the same one. Which is broken. So this tree is broken from here. So this is a touching like this. It is broken, and I forget that this is something. So it is like this. I suppose this is like this. So it is given that this is angle making angle 30 degree. The distance between the foot of the tree to the point where the top of the tree touches is 8 meters. It's 8 meters 30 degree. So this is my 8 meters. 8 meters. And this is 30 degree. This is 30 degree. So, oh no, sorry. No, but is due to the storm and the broken part bends so that the top of the tree touches on the ground, making angle 30 degree. So we can angle 30 degree with ground. Okay, so this. Now I will rename it that this is my A, this is my B, this is my C. This angle is 90 degree. What I need to find is the length of the tree. What in this case, what is the length of the tree? Length of this is this plus this. That is length of tree is AB plus AC. Now, sir, how I will calculate AB and AC? Now, this is given. So, in triangle ABC, angle C equal to 30 degree, angle B equal to 90 degree, and BC equal to 8 meters. From now, for calculating AB, AC is given. So, with respect to C, this is perpendicular. This is my base. So, tan I will do tangent. The tangent of 30 is nothing but AB by BC. AB is not given, so AB and BC is going to be 8, and tan of 30 degrees by root 3, which implies that AB is nothing but 8 by root 3 meters. 8 by root 3 meters. Now AB is going to now calculate AC. Now how will calculate AC? And for theta, this theta degree, this is my base, and this will be my hypotenuse. Base of hypotenuse is cos theta, so cos of 30 degree. Nothing but BC by AC. What says cos theta is nothing but root 3 by 2, and BC is going to be 8, and this AC. So if we calculate this, AC is given to be 16 by root 3. 16 by root 3. Now what is the length of the tree? Length of the tree is AC, AB plus AC. So what is AB plus AC? AB plus AC is nothing but 8 by root 3 plus 16 by root 3 equal to 824 by root 3 meters. Or if you simplify this as 24 by root 3 into root 3 by root 3 is nothing but 3 3 8 24, so 8 root 3 meters. 8 root 3 meters. This is your answer. This is your length of this thing. Now next question is third question. So what this third question says that it says that a contractor plans to install 2 slides for children to play in a park. For children below age of 5, she prefers to have a slide whose top is at a height of 1.5 meters and inclined at 30 degrees to the ground. Whereas for the elder, she wants to have a steep slide at a height of 3 meters and inclined at a 60 degrees to the ground. What is should be the length of the slide in each case? So it is given that. So we need to draw a slide. So this is slide number 1. Like this, and for this it is saying that she's saying that this is for below 5 years age, so this height need to be remained at 1.5 meters. An angle is not steep, so this angle to be 30 degree to the ground. So this angle is 30 degree. So this is my angle 30 degree, and it's for below 5 years. Below 5 years. This is your case, and this is I'm taking this A, this is B, this is my C, it's 90 degree, and this is I'm suppose this is my ground. Next is that for this thing greater than 5 years, she wants to have an 3 meter height and the angle is 60 degree. 3 meters height and angle is 60 degree. So this is angle is moved angle, so this will be steeper. Sorry. So this I will to join. The angle 90 degree and this angle is 60 degree. 60 degree, and this side it is given that this is 3 meters. 3 meters, and this I will take as PQR. She has installed 2 slides, so she wanted to know what is the length of the slide in each case. The length of the slide is nothing but you need to find this, and you need to find the length of the slide. So how will you find the length of the slide? The length of slide is first of all in triangle ABC. You can see that angle B is equal to 90 degree, and AB is given to be is the height of the swing is given to 1.5 meters, and this angle C is 90 degree. So if you apply this Pythagoras theorem, that is this for calculating, you need to calculate ACs for AC and for an AB with respect to BC. This is my perpendicular and this is my hypotenuse. So perpendicular hypotenuse is nothing but sine theta. Sine of 30 degrees is nothing but AB by BC. Sorry, AB by AC. So this AB is given to 1.5 meters, but AC I don't know. And but angle 1 by root 130 degrees half. It implies that AC equal to 1.5 into 2. This is 3 meters. AC will be by 3 meters. Now from here in triangle PQR, angle Q equal to 90 degree, comma angle PQR, angle R equal to 60 degree, and PQ is given to be 3 meters. So again applying tan of 30 degree to find tan of, so it's a tan of not 30, tan of 60 degree, angle 60 degree. Tan of 60 will be nothing but this is perpendicular, this is my hypotenuse, and the hypotenuse. So this is tan of 60, this is PQ by PR. So what is PQ? PQ is going to be 3 meters, and tan 60 is modulated into 3, and this PR I need to find. This PR nothing but 3 by root 3 will nothing but root 3 meters. 3 meters. So from here you can see that this height of this slide for below 5 years is 3 meters, and height of the slide for greater than 5 years is 3 meters. Now next question is the angle of elevation of the top of a tower from a point in the ground which is at 30 meters from the foot of the tower is 30 degree. 30 meters, 30 degrees, find the height of the tower. Height of the tower. So now this is my question number 4. Let's just say that this is given that this is my 90 degree and this is going to be 30 degree and point P of the ground. So this I can imagine to this is PQR, and this is going to be 30 meters. We need to find the height of the tower. So we just need to find. Now you can see that in triangle RQP, angle Q is 90 degree, angle P is going to 30 degree, and PQ equal to 30 meters. And now you can see that with respect to, I need to calculate PQ, and this what is given to me is PQ, and calculate this PQ is RP, I need to calculate PQ is my given, this is 30 meters. With respect to angle, this is my perpendicular across down, this is my base. So perpendicular by base, so I will be using my tangent of theta, and theta is theta in 30 degrees, so 30 degrees given by RQ by PQ. RQ I need to calculate, but PQ is given to be 30 meters, and 10 root 3, 10 30 degrees, that is given by root 3, so this is given by root 3, implies that RQ equal to 30 meter by root 3, which is nothing but 10 root 3 meters. RQ is 10 root 3 meters, which is my answer. This is the height of the tower. Height of the tower. Now, a kite is flying at a height of 60 meters above the ground. A string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string given that there is no slack in the string. Given that a kite is flying at a height of 60 meters, tied to a string is 60 degree. So 60 degree, 60 meters. This is my first question. So in that this is this angle is 90 degree, this is 60 degree, and the height of this is the plane is kite is flying is given to be 60 meters. So that's point P represent the kite, and this Q and this is R. So you can see that in triangle PQR, angle Q equal to 90 degree, angle R equal to 60 degree, and you can give the PQ equal to 60 meters. PQ is going to be 60 meters. So from here you can see that you need to find what is the length of the string, and so the length of the string nothing but RP is defined. Now as per this given, and this theta is 60 degree, and respect to this, so 60 degrees. So this is my perpendicular and this is my hypotenuse. So perpendicular hypotenuse is nothing but sine theta. Sine of 60 degree. Sine of 60 degree is nothing but PQ by RP. So PQ is given to be my 60 meters. RP I don't know, but I know that this sine of 60 degree is nothing but root 3 by 2. So I can write it as this is 60 by RP equal to root 3 by 2. This implies that this RP equal to 120 by root 3, which means RP equal to 3 for the 340. So 40 root 3 meters. This is 40 root 3 meters. This is the answer. This is the answer. Next, I will be doing sixth. Let me see the time. 5 minutes I am having. Not even 5 minutes. So, this is a 1.5 meter boy standing in the some distance of a 30 meter tall building. The angle of elevation is from his eyes at the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance here, walk towards the building. Okay. 30, 60, 1.5, 50. So this boy, and going just like this. Initially, and this is, suppose this is my building. So my point is the building. Initially, this is at point P. This is given to be my point P, and suddenly, and from this, it is given that the angle of elevation towards this is given to be 30 degree, and when it moves from the suppose this point P to this point Q, the height, since the height the bonding distance, so this I suppose that this from here it is the angle of deviation is like this. So if you see this diagram correctly, this is my ground level. This is my ground level. It is given that this angle is increased to from 30 to 60 degree. Initially it was 30 degree and later increased to 60 degree, and the height of the building 30 meters, 1.5 meter boy. So this was 1.5 meters. This is the height of the building. This is given to be 60 meters, 30 meters tall building. This is 30 meter tall building. Now here travel is P to Q. So you need to find is this distance you need to find. Now I am taking this P, this is Q. This I have already taken as P, this is my P, this is my Q. And so this is my R and this is my S. And this angle is 90 degree. Now from here you can see that this distance will also be 1.5 meters. And from here this P, R, S, R, this is suppose this is T, my point T. So this ST equal to 30 minus 1.5, nothing but 28.5 meters. Now first see the triangle. So in triangle STQ, you can see that angle T is 90 degree and angle Q is 60 degree and ST is 28.5 meters. So you need to calculate. So this is my horizontal distance. So for this I need to calculate horizontally distance. So I need to subtract this two so that I can somehow get the value of this. So what is this? Is I need to calculate QR. So this only one relation is that this with respect to 30 degrees. This is my perpendicular and this is my base. So perpendicular base is nothing but tangent. So tan of 60 degree, nothing but this is ST by QR. And what is ST? ST is going to be, I have calculated this is to be 28.5 meters by QR. But it is not that this tan 60 by nothing else is 3 by 2. 3 by 2, which implies that QR equal to 28.5 into 5. Yeah, 28.5 into 2 is nothing 5 10, it is 17. So 2 to 4, 5, 57. 57 by root 3 meters. 57 root 3 meters. Now, QR you have calculated. You have to calculate PQ, PR. So in triangle, so now in triangle, ST, oh sorry, this is Q, let me suppose this is, no, this will not be correct, this is my Q dash. So my Q dash, this is my P dash. So, this is my Q dash, Q dash, Q dash R. So my triangle STP dash, triangle STP dash, what you see that angle T is 90 degree, angle T equal to 90 degree, and angle P dash is nothing but this P dash, this will be Q dash, this P dash is 30 degree, and ST is 28.5 meters. So you can calculate P. So for PR, for just angle 30 degree, this ST will be my perpendicular, this is my base. So I need to go as tan of tangent of 30 degree. So this is nothing but ST by PR. Now ST is given to be 28.5 meters. In PR you don't know, but angle when 10 30 you know already know that this is nothing but 1 by root 3. 1 by root 3. Now from here what you get that is PR is nothing but 28.5 root 3. 8.5 root 3 meters is PR. So if you want to calculate the value of PQ, you need to find this PQ. So PQ is nothing but PR minus Q dash R. Not just this PR, not just P dash R, sorry. This P dash R. P dash R. P dash R. This PQ or this PQ. P dash Q dash. PQ is nothing but P dash Q dash is nothing but PR. P dash P dash R minus Q dash R. So P dash R from this you can, this is this minus this will give you your answer. Will give you your answer. So and if you write this is nothing but 57 by 3 into root 2, which is root 3. So this is 3 under 3 23 19 to 19 root 3. So from here this is, you can calculate that this is nothing but PR dash is 28.5 root 3 minus 19 root 3. 19 root 3, which is nothing but 19 if you subtract 8 9, this is 9. This is, so this will be my 9.5 root 3 meters. So I have completed till question number 6. I have completed. From next time we will be doing question number 7. So keep watching the video, like and subscribe to the channel if you like.